going to generate a relationship between the fits and residuals. And you don't want that relationship to be strong. You want it to be very, very weak. That is, we don't want the model estimates to be related to the residuals. Because if they are, if there is a coefficient that's significant, it means that we've got heteroscedasticity. So we want it to fail the test. Unlike the regular regression model, we wanted to keep the coefficient. We want to make sure that coefficient is actually equal to 0. Okay? So check the p and the t values. All right, let's run it and see what happens. Go to stat, regression, hit a regression model. Instead of Lennar, this time I'm going to what? Estimate the squared residuals. Instead of these x variables, I'm going to use the squared fits. Okay? Everybody see what we've got? Just simple squared fits against residuals. And there we go. And I'm not interested in any of this stuff. There's only one thing I'm interested in relative to the BK test. And that is the t-value associated with the squared fit coefficient. See how small that coefficient is? 0.005. Everybody? I don't know whether you can see that or not. It's 0.005. That's pretty tiny. Look at the t-value. It's 0.56 or 0.55. Is that significant? No. Nope. Look at the p-value. It's greater than 0.05, isn't it? So this coefficient for the fits is actually has a high probability of being equal to 0. And that's what you want. Then you can definitively say that this is homoscedastic. It's not heteroscedastic. I want you to run that on your model as part of the project. It's part of your next assignment. Run the BK test. Everybody know how to do that? Do you? All you got to do is run the model, get the fits and residuals, save them, best model, square them, run the fits against the residuals, and get the coefficient, t-value and p-values. And you want them to be non-significant. You want that coefficient to be non-significant. And logically, that means that should be the case. Because if there is some sort of relationship between them, it means there's some variation in the residuals that could be explained by better specification. And in this case, and from a linear perspective. And what we're finding out that's not the case. So there's no heteroscedasticity, it's homoscedastic. So that as you move out over time, you don't have to add a constant value to it to adjust the model, to make it equal to the fits. Makes sense. Okay? So how do we forecast with this baby? You have to go back to the original model. Make sure you do this. After you check for BK, you have to go back to the original model that you ran. Because to forecast, it has to have a model in there that's viable. So we have to go back and put Lennar in. And the continuous predictors that we used last time were the squared unemployment, right? And the square root of Pulte. Isn't that what we had? As variables? Because we tried to cure the, tried to improve our model relative to serial correlation. This is the best one we had. Okay? And by the way, do we have seasonality in those residuals? I've got to ask you guys. Let me cancel this. Do we have seasonality in the resids that we got from the model? Check for that. You know, we can do a time series plot of them again if we want to. You've seen that before in the 4 and 1 plot. So residuals 14, yeah. And you can see that it's still got a strong cycle pattern. I don't see any seasonality rearing its head, do you? And we can check it though with stat time series what? ACS, right? Correlation functions. And we want to put the, look over here, it's probably easier, and then put the residuals 14 in there. And it doesn't look like it's got really significant seasonality, but there is strong cycle in it early on. Okay? Actually, it's more recent cycle. So we don't have to worry about seasonality. If you're concerned that you've still got seasonality, you guys know how to account for it, right? Do I need to go through that again, or do you guys know how to build that little matrix? You guys remember that? Huh? Let me do it for you quickly. Let's go back to the data. And we got recession. I'm going to open up a couple more columns. We only, for quarterly data, we only have to have 3 columns, remember, because we don't want to, cells. We don't want to introduce multicollinearity. Q2, Q3, Q4. So I'm leaving one of the quarters out. This is first quarter, 0, 0, 0. Second quarter, 1, 0, 0. Third quarter, 0, 1, 0. Fourth quarter, 0, 0, whoops, 0, 1. Okay? Just copy this and paste it. Control copy, Control V. Paste it again, Control V. Copy this whole thing, save some time. At least I think I will. Control copy, Control V. Still first quarter. And here we end with what? 0, 0, 0. Okay? Let's run the model with those seasonal factors in it. See if we can get any of them to regression. Fit regression model. We're going to put these in continuous, right? So I'm putting these seasonal dummy variables in continuous. Let's run the model. Oh, it helped the Durbin-Watson statistic, didn't it? Brought us in the range, but let's look at see if they're consistent. I mean, none of them passed the test. Okay, Q2 is close. Let's take out Q3 and Q4. Maybe Q2 will improve. Let's go back to regression. The regression model. Take out Q3 and Q4 and leave Q2 in. See what happens. That what idea? Squared fit? What in the world? How'd that get in there? Let me rerun that model. Regression. I don't know how that squared fit continuous predictors. Squared residuals. And what it did is went back to, oh gosh, let's rerun this again. Q2, Q3, Q4. It went back to that original, the BK test that we had. I'm sorry, you guys. Don't mean to confuse you. Forecasting LR, but we're using what? Square root of, whoops. That's a continuous variable. We're using square root of unemployment. And we're using square root of quilting. And plus these seasonals. The seasonals that work. It didn't help the Durbin-Watson statistic, did it? See, the first time I ran it with, the old BK test. Q2 doesn't, it's not significant, is it? T-value is too low. P-value is too high. Q3 is not significant. T-value is too low. P is too high. Q4 is not significant. So I don't have significance now. Yes?
So if even even though you don't have significant
Huh?
seasonality, even though you don't have significant seasonality, you still want
No,
us to
run.
show it?
No,
Okay.
you don't have to show it. Remember, you're only gonna show me one model, okay? It's gotta be the best one. I wanna see a bunch of trials. I don't wanna see you go from one thing to another. You just show me the best as you go. Just talk about what you've done. If you wanna check it, make sure, put that matrix in and check it very quickly to see if there's any significant seasonality. But you ought to be able to detect that with the ACFs, right? And the time series plot. It looks like it's got seasonality in it for the shark's teeth we talked about, raw data does. And you may have to use those seasonal dummies. And if the ACF's got a 4th period spike on it, you know, where it rises above the other ACFs, you need to check it. Look at the shark's teeth in the original data, check it with the spikes in the ACFs, 4th period. And if it's not spiking, you don't have shark's teeth, don't bother running it, okay? Don't bother including those variables in your model because they're not significant. You need to take them out, right? So you can talk about what you've done, but these, if you've got seasonality, these would have to be significant and they'd have to show up in the model that you showed me, okay? Has everybody got that? I don't want to see, you know, experiments. Show me what you've done, okay? But if you do run a model and the data clearly has seasonality in it, and you have a residual plot, you know, 4-in-1 plots that you're going to paste and cut and put in there, and it shows seasonality in the residuals, guess what? You didn't specify the model right, right? You should have had the seasonality in it in terms of capturing it with X variables. We got barely time to forecast. Let's see if we can do it. Stat, regression, fit regression model. Take these babies out, right? Okay, and run the model again. So make sure you run the model that you want to use. Stat, regression. Then go back and rerun the model. This time, instead of fit regression model, I'm going to predict, okay? It says you're going to predict Lennar. I don't want to enter the variables, I want to enter the column values. So it's going to point to the data, some of the data I've had. Remember I went to all the trouble of creating those holdouts and forecasts, right? So now what I'm going to do is it says square unemployment. I didn't create a square unemployment, did I? Fudge. So I'm going to have to take square root of Pulte and square of unemployment in the forecast. There's a Pulte. So insert a column. Square root. Pulte. Oops. I've got my hands in the wrong place. And I put this in the wrong spot, didn't I? Right when I'm, okay, got a calculator. Square root of Pulte forecast. Square root. Put Pulte forecast in it. Then I need the unemployment squared, right? Insert column. Calculator. Square of unemployment forecast. And there. Go to forecast now. Stat, regression, predict. Enter column values. Square of unemployment, look for the forecast of that. Square unemployment forecast, right here. Square of Pulte, square root of Pulte. Square root of Pulte, where is that? I put that in the wrong column, didn't I? This should be square root of unemployment. And this should be square root of Pulte. I just had the wrong things in there. Okay? See that? Just put the right data in the right column. This is square of unemployment. I have square of unemployment forecast. That's what I needed. Square root of Pulte is one of the variables. I need the square root of Pulte forecast. Okay, storage, you want the predicted values, and I want the confidence limits. Store it, bang, there we've got a forecast that resides right here. And you can check that forecast stat, time series plot with a multiple. Look for the holdout, Pulte or Lennar. Look for the forecast, the limits. This is what it looks like. This doesn't do a bad job. See the actual Pulte data in the blue for the holdout. The forecast is in red, and it stays within the confidence limit, so it's not a bad forecast. Okay, and you can calculate the fit or forecast error. The forecast resids. And the way you get those is go to calculator and you put in the forecast resids. What you do is subtract the forecast from the holdout. Holdout minus forecast. That's P fits. And there you go. Look at the forecast make. Absolute value of the forecast resids. Divided by the holdout. Sum those. And you got a make of 12.9%, 13% error.
What'd you divide by?
Number of observations for the forecast, 8. Okay. Anyway, that error measure is pretty high, but the forecast doesn't look too bad. 12%, 12.96.
Oh, yeah.
Okay. So we need to get out of here. We got another